Ladies and gents, my name is Brandon Stover. Welcome to the How to Solve Climate Change course from Plato University. Causes, systems, obstacles, solutions to this global challenge is what you're going to learn here today. When you're ready to learn more skills, join us for free at plato.university. Let's get started with today's lesson. We'll have our expert guests briefly introduce themselves and their credentials for why they are able to speak to this topic.
Yeah, so I am the Global Climate and Ocean Lead at the Nature Conservancy. So I lead on our global policy, science, markets, and implementation strategy around ocean climate solutions.
And explain succinctly what blue carbon is from first principles.
Yeah, so blue carbon, as we define it, is the carbon that is stored and sequestered in ocean ecosystems. We currently focus mostly on coastal wetland systems, so tidal salt marshes, mangroves, seagrasses, because they're the most well understood and studied. Other ecosystems include kelp/seaweed, ocean sediments, but again, those are still have a lot of science gaps. So we more focus on science around those ones rather than a full implementation.
Why does blue carbon work or help to solve climate change?
Yeah, so at the Nature Conservancy, we really care about, obviously, nature and finding a way where people and nature thrive. And so blue carbon is one of those opportunities where not only does it mitigate the impacts of climate change through its carbon sequestration, it also promotes biodiversity and helps with climate adaptation.
I would like to add that blue carbon helps to solve climate change by sequestering and storing significant amounts of carbon dioxide from the atmosphere. Coastal ecosystems can capture carbon through photosynthesis, and much of this carbon becomes stored in the soil below the water surface for long periods. Protecting and restoring these ecosystems can enhance their carbon storage potential, thus reducing the overall concentration of greenhouse gases in the atmosphere.
Why might blue carbon not solve climate change or fall short?
I think right now there's a lot of momentum around coastal wetland systems, and it's extremely exciting that they're finally being recognized for their value, especially around the carbon mitigation. But they are small systems and they are complex systems. So it isn't just as simple as plant a mangrove in the same way that it is like plant a tree. It requires hydrology changes. So you need to make sure there's fresh water flowing into the mangrove, so that it requires upstream management. It also requires that the salinity be a certain level. So you need to make sure that the tidal flows aren't being blocked. So it's much more complex than, that terrestrial plant a tree. So that makes it expensive. And sometimes when people see that expensive price tag, it's less desirable. And then also it doesn't step up when you think about it from just a climate mitigation when it goes against terrestrial forests. While per hectare they store more carbon, overall they're just a sliver of the.
Who benefits most and who may be harmed most by implementing blue carbon as a solution?
You know what? Everyone benefits. 90% of all commercially caught fish spend at least part of their life cycle in a coastal wetland. So if you eat fish, you should be thanking coastal wetland systems. Again, they're really important for coastal adaptation. They're the front lines of storm surges. And talk to any person who owns a boat in the Florida Keys. They are docking their boats behind mangrove forests because they know that that's what's going to protect them when a hurricane hits. And you can see even the images of like the boats not near mangroves and the boats near mangroves. It's completely a different situation for the ones who are able to get that kind of property right by the mangroves, because it's just so important for protection. And so it's everybody benefits from coastal wetland systems, because climate mitigation obviously benefits even the person living in the middle of the U.S. from the impacts of climate change. The people who probably don't benefit, real estate. Everybody wants beachfront property, right? And they want the beautiful view of the coral reefs and the coastal beautiful sands. So there is a huge amount of deforestation for that reason. Also, infrastructure, it's expensive to do roads that allow for fresh water and hydrology flows underneath it. So you have to put like culverts in, and that can cost millions of dollars rather than just putting a slab of road. But you put a slab of road in, you stop the coastal water flows, you're going to eventually choke out And and again, like with climate change, the waters are rising. So coastal wetlands do need to migrate inward. And so when you have this hard infrastructure from cities and from roadways, they're eventually going to die because they're going to be squeezed. So I think people don't always think that because they want to do what's the cheapest and fastest when you're thinking about infrastructure development. But if you want to save these systems, you're going to have to spend more money.
Can you explain further how blue carbon works, this sequestration into the ocean waters?
Yeah, so actually, it's not as much about the sequestration in the water. So these are plants. So they do regular photosynthesis, where they store the carbon in their biomass. But what really makes them unique is it's the carbon stored in their soil. So about 90% of their carbon value is actually in their soil. So what happens is when leaf litter from the trees fall into the water, they're actually caught by the roots of these systems. So by the seagrass roots, the mangroves and tidal marshes, and then they slowly decay. But because it's saltwater, saline water, it actually limits the methane emissions. So as it goes into the soil, it's compounding and all that carbon is staying there. And unlike a lot of terrestrial forests where you kind of reach a peak point where you can't store or sequester any more carbon, these systems actually keep sequestering carbon over thousands of years. And the soil accumulates, it kind of gets more densely packed. So that's why it's such a problem to lose these systems, because you're emitting thousands of years of carbon that's been stored in these soils. And it's also, and it should be stated, that the carbon is just from the carbon leaf litter. As I said, it's really important to have hydrology flows from freshwater systems. So you'll also have rivers and streams that have their own kind of siltation and their own leaf litter that come in. And then the roots of the systems also store those. So there's two kind of carbon sources that we see in coastal wetland systems. We call it in situ and ex situ. So those are kind of like how it works in a nutshell. It's much more complex, obviously.
Excellent. And for this to work as a solution, what innovation or policy may need to be put in place?
Well, I think I talked to you a little bit about the roadways. So I think there needs to be policies and development that really takes into consideration the needs of these coastal wetland systems. So we need to build smart. And so as we think about infrastructure, as we think about hotel designs, as we think about how that looks, we need to do that smarter. And so that comes with regulations, that comes with policy changes. Also, we really need to see a policy shift and just an ecological shift in how we do restoration of these systems. It isn't as simple as just like planting a tree. These are complex systems. And often communities don't know that. There's so many planting, especially of mangrove systems that I see, and 90% of planting of the mangroves fail. So it really is addressing the hydrology issues, needs to be forefront. And then if you want to plant, that's great. In some places, that is a good idea, but you need to fix the underlying conditions because these systems, like they kind of grow like weeds. I mean, mangroves are invasive in Hawaii. So if the conditions are correct, they'll be there. So you have to be questioning, well, why aren't they there? And I think the final kind of challenge that we see is really around the community and what is the livelihood that's going to generate the most income for them. Because obviously these people need to live in these coastline systems. And so there's a huge amount of pressure to deforest mangroves for shrimp aquaculture, which is one of the leading causes of mangrove decline in Southeast Asia. But when you're faced with the issue of protect your quarries, and then there's marine protected area in the ocean, really mangroves is the only strip of land you have to cultivate and use for your own income. So saying, oh, we can't use this now too, it's just not an okay solution. And so I think really figuring out what are the business positive models that we can use with around shrimp and around others that can both allow mangroves to thrive, but then the communities to thrive.
What are the best resources to learn more about blue carbon in relation to climate change?
First, I would say you should check out the Global Mangrove Alliance website. So there's a lot of really good resources on mangroves, different projects that are being done. And it is a great place to just have a 101 on that particular ecosystem. If you want to get a bit more nerdy, I would say there's some really good peer review papers on what is and is not blue carbon. So we have this paper that came out a few years ago called Clarifying the Role of Blue Carbon. And we just actually had an addendum that was published about 2 months ago that kind of goes into more details of some of these other systems. I think it's just important because there is still a little bit of uncertainty around some pathways that are being called blue carbon. So we really do need to clarify that for policymakers. And then if you really, really want to get into a whole lot of peer review papers, the Blue Carbon Initiative has a really great website, and it goes into different publications and different options there as well.
Excellent. Currently, you're speaking to passionate students who want to actually solve problems like these. What are the top 3 skills you think that they should study in order to do so?
Well, coastal ecology, it is good to understand how these systems work. They are quite complex, but just knowing the science isn't enough. I think policy is really important, and understanding how you can leverage different policy opportunities and moments. So right now, through the United Nations framework on the Convention of Climate Change and the Paris Agreement, there's a lot of opportunity to leverage coastal wetlands as a climate solution. So understanding those pathways can really bring the science and actually change something that way. And then, as I was mentioning, the pressures for communities, I think it really is important to have social science skills. And so really understanding what drives a community to make certain decisions and how can you help influence their decisions so you're doing what's best for the environment, but then also what's best for them.
Any final asks or recommendations for the audience?
Well, keep studying if they're all students. But also, if one of the, it's silly, but know where your shrimp comes from. As I said, shrimp is one of the leading causes in Southeast Asia. So it is always good just to look on the label. Is this shrimp from a shrimp pond or not? Because if you're buying shrimp pond, shrimp, you're leading to degradation of mangrove systems.
To dig deep into blue carbon, identify blue carbon ecosystems in your region like mangroves or salt marshes, explore their carbon sequestration potential, enroll in coastal protection.
Thank you for taking the How to Solve Climate Change course. If you want to learn the skills to solve this global challenge, join us for free at plato.university for exclusive content, extra resources, and actionable exercises with every lesson. This course was produced by Plato University, where students turn passions into purpose and learn skills to change the world. Learn more at plato.university.